This is Ahmed Al-Halak, and this is a recording or a screencast for the fourth lab in case that you haven't attended the fourth lab, or maybe you want to go back to some stuff that we have went through inside the lab. Just consider this as an alternative for the slides or the document or the fourth lab. There's gonna be a video for the third, the second, and the first as well. Okay, so let's start this. We said that the fourth lab is going to be about list methods. We're just going to extend on the list methods and recap some stuff that we have done before. We're going to introduce the tuples. We're not going to really work on them that much. I just want you to understand what does tuple mean. We have functions, and we're going to talk about unpacking values once we enter the functions realm. Okay, now let's just recap on this, what we have understood so far. We said that a list is basically just a variable that contains or holds multiple values. In this case, we have a list of 4 elements: Ahmed, John, Ziad, and Marwan. These are 4 elements. Okay, you don't necessarily make a list by naming the list as I'm doing here. You can make this any name. You can make this list name X, Y, Z, any name that you like. It's just a variable name. What's really important and what makes a list actually a list is how the list is defined. When you define a list, you have to definitely make the assignment operator, saying that you're assigning all of these elements inside this variable on the left hand side. But what really makes a list shines, and what makes Python identify a list, is basically the starting square bracket and the end square bracket at the end. Okay, so you know that a list is actually, or a structure that you have is basically a list once you see the starting square bracket and the end square brackets here at the end. Okay, so this is basically a list of 4 elements. We said that each element has an index or a position, and when you start counting the indices or the positions from the first element, you always start with index of 0. Okay, we go from left to right, and this is the case in every programming language. So in Python and every programming language, like speaking of C++, C, Java, C#, we start the first element at the index of 0, 1, 2, 3, and as you go. So Ahmed here has the index of 0, John has the index of 1, Ziad has the index of 2, Marwan has the index of 3. Okay, just remember something. In Octave or MATLAB, we said that the first element always starts at 1. That's the difference that you need to remember. Okay, so in Octave or MATLAB, the first index or the first element starts at index of 1. But the first element in Python and most of the programming languages start at the index of 0, as you can see here. Okay, so in order to access an element, you say that you're gonna write the list name. We named this list list like this. So you write the list name, which is list in this case. You follow the list name with a square bracket, a starting and an ending or a closing square bracket. The most important thing is the position or the index of the element that you want to retrieve. In this case, let's say that we want to retrieve or return the value of Ziad, which is basically 1, 2, 3, which is basically the third element that has the index of 0, 1, 2, that has the index of 2. So basically when you say a list of 2, you're gonna return Ziad. That's why when we print list of 2, it's gonna return to you Ziad. Okay, now we discussed the 3 possible ways that you can get the last element from. The first one is basically by counting. If you have a list in front of your eyes like this, you have a defined list and the elements are just basically clear to you, you can basically count. So you're gonna say 0, 1, 2, 3. So you're gonna, by counting, you know that the last element is gonna be at the index of 3. So if you said list of 3, this is gonna return Marwan. Okay, there's another thing that is basically Python specific, which you can count backwards from right to left. If you start and count from right to left, you should reverse the indices. So basically, if you count it from right to left, the first element from the right, which is basically the last element, is going to be at the index of -1, Ziad -2, John is -3, Ahmed is -4. So -1, -2, -3, -4. That's if you want to work on the negative indices. And remember, the negative indices is something that Python only can handle. You want to find something called negative indices inside C++ or C. The most common thing, or the universal thing, is the normal positive indices from left to right, which is 0, 1, 2, 3, 4. 0, 1, 2, 3. I'm sorry about that. Okay? So if you want to use the negative indices to access the last element always is at index of -1. So list of -1 is going to get you Marwan. It's the same thing as list of 3. Okay? The one way that I told you that you should actually adopt is the following. If you remember, we told you that you can get the count of the elements, the number of elements, or basically the length of the elements, using something called the len function, which stands for the length function. Okay, so the length or the len function, basically it's a function, so it has a name followed by 2 parentheses. Like any function, you have this print is a function followed by a parentheses and a closing parentheses. Okay, the length function takes any list inside of it. Okay, so you pass a list into the len function. The len function returns you the number of elements inside this list that you have passed. So let's say that this list has 4 elements. When you say len of list, this is going to be substituted with 4 because we have 4 elements here. When you say -1, you're going to say that the length of the elements -1. So 4 in this case, -1. All of this is gonna get substituted by 3, which is basically the last index. And you can actually observe this because we start the count from 0. The last element will always be the number of elements -1. Okay, so let's say that we have 4 elements. The last element is always going to be at 3, 4 minus 1, which is 3, because we start at 0, 0, 1, 2, 3. Let's say that our list is 3 elements, so the length of it is 3, right? But the last element, which is in this case, is going to be Ziad, is going to be 3 minus 1, which is 2, 0, 1, 2. Okay, so basically, the number of elements, which is the length of the list, -1, always returns you the last index. Okay? The last index of the last element. So last index is going to have the value of 3, using the same accessing techniques that we have introduced here, saying that the list name, square brackets, and closing square brackets, and inside we pass the index, the desired index of the desired element. We're going to say list of 3, which is in this case stored in the variable last index. Okay? If this is confusing you, just remember that when last index is substituted implicitly by Python, this is going to be replaced by the number 3, which is basically the same thing as this. And this is going to return, all of these 3 methods are going to return the last element, which is in this case Marwan. Okay? We introduced something called slicing, which is basically returning a range of values. Now notice something. When we pass one element, when we pass one index inside the square brackets, we will eventually retrieve one element. When you pass one index, you're gonna retrieve one element. Okay? But when you pass a range like this inside the square brackets, this range is basically called a slice, which is a subset of the list. Say that you want to have the subset of the list called list starting from the index 1 to 3. So 1, we have 0 here, 1 is John, 1, 2, but remember, I told you in the previous lab that the end is excluded. We don't have this end with us. So basically, you're not going to retrieve John 1, Ziad 2, and 3 Marwan. You're just going to retrieve 1, 2. So basically, Python stops before the end, which is at before Marwan here, before the third or the fourth element. Okay, so you're going to have John and Ziad. Okay, and basically this is the start parameter, which is included with you. you get John if you start with 1, and this is the end parameter, which is Marwan, which you don't get when you return any slice, it's excluded. And this colon operator is called the range operator. It's something like 2, like saying from 1 to 3. Okay? Alright, so let's discuss this slice. Let's take the first part where I have introduced this. It's the same thing as this. Notice that this is the first parameter, this is the colon or the to operator, and this is the end. If you notice, we have not specified an end here. So basically, how Python interprets this is the following. You set this that the start is 0, which is the first element, and not specifying an end means that you want to go through till the end of the list. So this is what Python does. If there's no end, Python's gonna take the start that you have specified, which is in this case the first element or 0, and it's going to run through all elements. It's gonna grab all elements. Okay? But what does this part do is the following. If you include another colon, basically the parameter, the third parameter after this colon is called the step, the jump. How many elements do you want to skip? So let's say that you have from 0 to the end, which is this part, 0 to the end. An empty end is basically grabbing all elements. So from 0 to the end we have all of this. Okay, when we say a step of 2, what happens is the following. You start at 0, you step by 2, so basically you skip the 1 and you come to the second, so you have Ziad, and this is basically what's gonna be returned, Ahmed and Ziad. Okay, you're now on the index of 2, Ziad. Okay, you're gonna step by 2 one more time, you're gonna skip the next one, but there is no index of 4, so basically this is what we get, Ahmed and Ziad. If you make the start by 1 and the step is 2, so basically you're getting the odd indices. Okay, so the odd indices is John, okay, at 1, then we're gonna skip Ziad and step by 2, so we have 3, we get Marwan, and this is it, John and Marwan. That's if you have started with 1. Okay, reversing a list, I'm going to talk about this shortly. Okay, we said that we could do the same thing on strings. Basically, you can index and slice any iterable. And what does iterable mean? It's just a collection of stuff. An iterable in Python is a collection of elements. In this case, when we have a list that starts with a square bracket and ends with the square brackets, we say that this iterable is a list. Okay? In this case, when we have something that starts with a quotation and ends with a quotation, we know that this shape or this look is a string. But Python treats the string as an iterable as well, because when Python goes through this string one element at a time, it figures out that this string has 4 elements, which are 4 characters. Okay, so a string is as well an iterable, just like the list. In this case, we have a string or an iterable. We have a string of 4 elements or 4 characters, if you may. We store this this string in a variable called word. You can call this anything, x, a, b, anything. Okay, just as I stored this list in a variable called list, I'm doing the same thing here. I'm storing this string in a variable called word. Now, accessing a character, you can actually access a character, because remember, this string to Python is a collection of 4 characters. So you can actually get any one of these 4 characters, and they have the same indices and the same numbering system as the lists. The first character always starts at index of 0, the second character 1, 2, 3. So we have 0, 1, 2, 3. Okay, say you want to get the element or the character A, so you're gonna say the name of the string. It's the same thing here, the name of the list followed by 2 square brackets, and inside the square brackets you give the index of the element that you want to retrieve, which is, if you want to retrieve Ziad at index of 0, 1, 2, you're gonna say 2, list of 2. The same thing goes here as well. So the name of the string, the name of the variable that holds the string, okay, followed by 2 square brackets. Inside the square bracket, you give the index of the character that you want to retrieve. Say you want to retrieve A, which is at index of 2, so you're going to say word of 2. So word of 2 is going to get you A, because 0, 1, 2. Okay? Now, getting the last element has the same exact fashion as the lists. So you want to get the L, which is the last element. So you're gonna, if you want to count, it's up to you. So you're gonna say 0, 1, 2, 3. So word of 3 is gonna return L. If you wanna use the negative indices, remember that in strings there are negative indices as well, just as the list have -1, -2, -3, -4. Our string here can be indexed just in the same way, saying -1 if you want to walk backwards from right to left. This is -1, -2, -3, and -4. So word of -1 is going to get you L. Okay? Now, and remember, this is only negative indices only work in Python. Okay? So the last method, which is the most reliable one in most of the languages, is getting the length of the iterable, getting the length in this case of a string, in the same exact fashion that you can get a length of a list. You can pass to the len function another iterable, which is another collection of elements, which is in this case is the string deal, which is stored in word. So if we told the len function, get me the number of characters or the number of elements inside this iterable or inside this string that is stored in word, it's gonna get you the number of characters inside this word, which is basically 4. Okay, so this is gonna be substituted by 4. All of this, the highlighted stuff here, is gonna be substituted by 4. 4 minus 1 is gonna get you the last index, which is L3. 3 is gonna be stored in last index, and when we say word of 3, it's gonna get you the L, which is basically the same thing as this. Okay. You can actually slice a string as well, just as you can slice a list. So let's say that we want to get the EA, this part. So this starts from index of 1, 2, till 3. Okay? If you set from 1 till 2, so 1, it's going to stop before 2, so you're going to get only E. But when you say 1 till 3, it's going to get you 1, 2, and it stops before 3. If you said 1 to 4, it's gonna get you 1, 2, and 3. Okay, but if you like not included an end at all, like left this end parameter empty, it's the same thing as saying 1 to 4. It's gonna get to the end, so it's gonna get you 1, 2, 3. Okay. Okay, so you can get the even indices as well, saying from 0 till the end. The end here is empty, so this is basically interpreted as from 0 till the end. 0, 1, 2, 3, 4. But with a step of 2, so you're basically getting the 0 because you started at 0, 0, 2, so you're gonna get DA. Okay, and the reverse is gonna be like introduced shortly. I remember that I have talked about this in the previous lab, but I just want to stress this, so I'm gonna illustrate what reversing a string or reversing a list actually mean. Okay, now we have said that the for loop has two actual usages. We have like using the for loop as a number counter, and we have the for loop to access the actual elements. And I'm going to illustrate this just in a moment. So let's get to VS Code. Now let's say we have the same list we've been introducing before. We have Ahmed, John, Ziad, and Marwan. To get all elements, we can say, let's make a print function first to see everything get printed in the terminal. We say the list name, which is called a list with a capital L in this case, is followed by 2 square brackets. Inside the square brackets you get the element that you want. But remember, getting all elements means that you need to do something called slicing, the thing that we've been talking about shortly. Okay, now let's say that we want to get all elements, so you start from element of 0 or index of 0 till the end. If you want to specify the end as 0, 1, 2, 3, remember if you put 0 to 3, you're gonna get 0, 1, 2. The 3 is not gonna be included. So you can say from 0 to 4, this is gonna get you everything that you need. Okay, and you can leave the end empty like this. There is no end specified here, so this is gonna get you the same exact stuff as well. Okay, and remember the default step is 1. Notice how we were counting. We were saying 0, 1, 2, so we were incrementing by 1. That's why the default step is 1. So you don't actually need to write the step when the step is default by 1. You can write it like this. It's gonna give you the same result, and you can actually like remove this part. It's the same thing. Okay, now let's say we're gonna reverse this list. Okay, let's say that we have this list and we're gonna reverse it. Reversing a list, remember, you want to see in the terminal Marwan, then Ziad, then John, then Ahmed. So let's start from the last index, which is, if you want to take it like in a backward way, so let's say from -1. Okay, we want to say -1, -2, -3, and -4. Notice that we are decrementing or incrementing with a -1, so you need to specify the step as -1. Okay, in order to walk backwards, or to tell Python that you're walking backwards, and -1, -2, -3, and -4. This is the thing that you need to do. Notice that I haven't specified an end. You can say that you're walking negatively from -1, -2, -3, -4. So basically, if you wrote -4, you're not gonna get Ahmed at the end. You're not just gonna get Marwan, Ziad, and John. So you can just add another -1 in order to get the -4 here, or the first element, so you get Ahmed. Okay, and you don't have really to write or specify an end at all. You can just remove this end from here, and Python understands that when you specify a start of -1 and you give it a step of -1, Python is just going to start from -1, and when there's no end specified, it's just gonna continue till the last element, in this case the first element. Okay, so this is one way to reverse a string. And what's really common, and what you're really gonna see on the internet, is that you can actually not specify a start or an end. You can just specify a negative indices or a negative step. Python understands that when you specify a negative step, this means that it puts the default start as the last index, and it puts the default end as the first index. So it's gonna go from right to left like this. Okay, so these are gonna give you the same result. This is related to this print function, and this is related to this print function. Okay, okay. We can do the same thing with a string. We have an iterable. I kept saying this a lot, and basically an iterable is a collection of elements. Okay, these elements can be characters, just as we have an iterable that is called a collection of characters, which is in this case is called a string, and we can have an iterable that is a collection of elements that starts with a square bracket and ends with a square bracket, and this is called a list. Okay, so an iterable can be a list. It can be a string, and these are the two types of iterables that we have taken so far along the course. So let's say that we get all characters of this string in this variable called word. So we will need a print function. Let's say that we are slicing the word from the first index till the last index, so I'm not going to specify an end. So this basically gets everything. And let's say that we are reversing the elements or the characters in word, so you need a negative step. Okay, and you need to start from the last element, which is -1, to go till the first element from right to left. So this is going to get you the element reversed, or the string reversed. And just as I told you, you can like remove this start and end, and it's really sufficient for you to give the index of -1. This is really enough to like reverse a list. It's going to give you the same result as the first one, which is this one. Okay, now let's see what we meant by using the for loop as a number counter, and what we meant by using the for loop to access elements. Okay, so remember this program where I told you to print the numbers from 1 to 10? Let's say that we needed a for loop and we called like for x, and the most important thing when you need to print numbers from like any start to any end, okay, you want to print some sequence of numbers, you're gonna need to use the range function, because the range function actually gives you a sequence, a collection of sequence number based on a start that you're gonna give and an end that you're gonna give. So that's what we need in this case. We need to print the numbers from 1 to 10, and basically x is going to be each number from 1 to 2 to 3 to 4 to 5 to 6 till the last one, which is 10. So x is gonna be every number between the range of 1 to 10. This is not entirely correct, because if you remember correctly, I told you in the range function the end is excluded. It's the same thing as in the slicing. In the slicing, the end here is excluded. That's why we always needed to like increment the end by 1 if you want to like reach, if you want to reach from, let's say, you want to get from 0 to Ziyad, for example. So this is 0, 1, 2, right? If you said 0 to 2, this is not okay. Let's just comment this now. Let's go to this example. If you said from 0 to 2, the index of 2 is not gonna be with you. Okay, so you're just gonna see 0, which is Ahmed, and John, which is 1. Okay, so in order to get Ahmed and John and Ziyad, you need to increment the end with 1. So this is going to be from 0 to 3. This is going to give you 0, 1, 2. Ahmed, John, and Ziyad. Okay? The same concept with the end regarding the slice inside a square bracket actually applies in the range function. The end of the range function is not included. Let's say that we're going to print the x now. What you're gonna see printed is 1, 2 till 9. So the end is not included. So just remember to add 1 to your end if you're starting from 1. Okay? So in this case, if you run, you're gonna see that you have 10, but obviously 11 is not included with you. This is using the for loop as a number counter. Okay? Now let's take a closer look on this for loop. You have created a for loop with a variable called x. This is the for loop variable. The x, or the variable of the for loop, is gonna like be in the first iteration 1, the second iteration is gonna be 2, the third is gonna be 3, and stuff like this. So let's say that this loop is gonna run for how many iterations? Just think about it for a moment. Exactly, the first loop, this loop is gonna run for 10 iterations, because you started from 1 and you stopped at 10. The 11 is not with you. So basically the range function generates the following sequence of numbers: 1, 2, 3, 4, 5, 6, 7, 8, and 9, and finally 10. So basically what happens implicitly is that the variable of the loop in the first iteration is going to be 1. The x, or the variable of the loop, in the second iteration is going to be 2. In the third iteration, the x is going to be 3. In the fourth iteration, the x is going to be 4, 5, 6, 7, 8, 9. And in the last iteration, or the 10th iteration, the x is going to be 10. So let's take this one by one. If you run this, you're going to see that from 1 to 10 is going to be printed. But what happens step by step is actually the following. It just, you see this printed immediately, but what happens is the following. So basically the first iteration, x is going to be 1. So x is going to be substituted by 1 inside the for loop block. Okay, this is the for loop block. Remember that when you go a new line like this and there's an indentation, a small indentation like this, you understand that you are still inside the for loop block. Okay, go another new line, go another new line. As long as there's an indentation level here, you understand that all of these lines, this line and this line and this line, and even the print line, all of these are relevant to the for loop block, and all of these lines that has this indentation level are going to be executed inside the for loop block. Okay, and once you have removed this indentation like this and you are standing in the same level as the for loop, this is what we call that you have exited the for loop. or you have ended the for loop, and anything that comes afterwards is not related to the for loop by any means. Okay, so let's say in the first iteration that the x is going to be 1. So the Python, when x is 1 in the first iteration, prints the x value, which is in the first iteration is going to be 1. That's why you see 1 is printed. When this print function finishes, you go to the new line. This basically what happens to it with the Python interpreter. This is what Python actually executes. So when this print function finishes, Python goes to the next line, and it finds that there are no next lines. So basically it goes back to the header of the loop just to check, did we reach the end? Did we reach the last iteration? So I might as well get out of the loop like this and execute the rest of the code, or are we still within the for loop iterations? Are we still within the for loop? So this what happens. The x was 1, so basically when Python returns to the header of the loop, it does not go out, by the way. It always returns to the header of the loop and checks, did we reach the last element? So should we go out of the loop now, or are we still inside the for loop? So after the first print, which is the 1, the control is back to the header of the loop, and it checks, Python checks. Now we have the second iteration where x is going to be 2, so x is going to be updated to be 2. Python goes into the for loop blocks and it prints the x when it's 2. So you have this 2 printed inside the terminal. Python finishes this print functions and it goes to the next line. It finds that there are no next lines, so basically it goes back to the header of the loop and asks itself, did we reach the end? Did we reach the last iteration? And it's definitely, the end is not reached. So in the third iteration, x is going to be 3. So basically Python goes inside the for loop and updates the x value with 3, and it prints the 3 in the terminal. When this print is finished, the same exact process goes on, and basically it goes to the next line. Okay, there's nothing, but I will not break out of the loop, I will not go out of the loop until I check the header. So it goes back to the header of the loop and it checks, did we reach the last element? We definitely didn't reach the last element, because now the iteration is the fourth iteration and the x value is going to be updated inside the for loop block by 4, and it prints the 4 in this line, and it goes on until it reaches the last index or the last iteration. Okay, so this is what I mean by using the, I'm going to be more specific here. Let's say using the for loop variable as a number counter. When I talk about the for loop variable, I'm meaning the x. We can name this anything. It can be y, it can be element, it can be e, anything. Okay, so using the for loop variable x as a number counter, it's going to be basically something like this. The most important thing as using the for loop variable as a number counter is following the n operator, which is the membership operator, if you remember, by a range function. Okay, don't forget this. Following the n operator with a range function, this is basically you saying that x is gonna be a number from this range start to the end of the range. Okay, let's get this to be x. Now let's check the other usage for the for loop. Basically, when you have an iterable like this list in this case, how did you know that this is a list? You have a square bracket at the beginning and the square bracket at the end. Okay, this list is called courses. Okay, and this list has 4 elements, 0, 1, 2, 3. Okay, I told you that you have 2 ways of accessing elements of a list using a for loop, and you can find this in the third lab, the previous lab. I'm not going to go through both techniques. I'm just going to mention the easiest one, which Python actually provides us. So you can say a for loop. You eventually you're going to need a for loop, because if you didn't have a for loop and you wanted to print all of these elements, you're gonna need basically a print function that equals the number of the elements here. So let's say we have 4 elements, so you're gonna need 4 print functions, starting from courses of 0, then courses of 1, then courses of 2, till courses of 3. I hope you get the idea. So we can use a for loop that actually iterates 4 times, because we have here 4 elements. Okay, oops. Okay, and basically this means that the loop is going to be iterated for how many iterations? Exactly 4 iterations, because we have 4 elements, so it's gonna go for 4 times or 4 iterations. So we have a for loop. We're gonna use the for loop variable as x as well, just as the previous for loop. N, you're gonna need the n, or the membership operator. The most important thing as using the for loop to access the elements themselves is what follows the n operator. If you follow the n operator with a range function, then basically the x is gonna be a number in this, a number that represents each element in this collection of numbers. But when you follow the n operator inside the for loop with a list, in this case we have the list that is called courses, basically when you print x now, just look at the output for a second and you're going to understand what's happening. The x here is basically the element themselves. So again, if you follow the n, or the membership operator, inside a for loop with a list name, any list name, and we happen to have this courses list in this case, the variable of the loop in the first iteration is going to be the first element itself. That's why you see that this database is going to be printed. The second iteration, when the for loop is running, is going to be the second element, which is the data structures. In the third iteration, the x, or the variable of the loop, is going to be the third element, which is algorithms. In the fourth iteration, the x is going to be the fourth element, which is security. So when we say for x in any course, in any list name, this basically makes the x as the element itself. Okay, the x is not a number. The x is not a number counter anymore. Okay, the x actually does not represent a number anymore. It represents, when you say in a list name, in this case in courses, x is the element itself. And how many times would this iteration go on, or would this loop go on? The thing is, the number of iterations that this loop will continue to be executing itself is dependent on the number of elements. If you have this list of 4 elements, then you have 4 iterations. In order to let Python substitute this x with each element of the 4. If you have this list, if it happened to have like 3 elements, then this list, or this for loop, is going to execute for 3 iterations, because you have 3 elements now, right? So you're going to see only database, data structure, and algorithms getting printed. Okay, I hope this is clear. Now, just to recap on the list methods. I told you that if you made a list just as I did here, and you left the list just as empty as this, meaning that you have not included any elements, like this, a list that does not have any elements is called an empty list. This is the looks of an empty list. And by the way, when you see something like this, when you have like 2 quotations and there is nothing between the 2 quotations, this is called an empty string. Okay, so just take this and remember it. Okay, so this is an empty list. I call this list names. Let's see how can we append names. In the beginning, let's print names and see what does names have. When you print names, it's going to give you the empty list that you have defined at the start. Now, appending is basically adding to the end. Let's say that we want to append the name Ahmed to this list, to this empty list. So we say the name of the list, then the dot operator, and after the dot operator it's gonna like suggest some methods that you can do on this list that is called names. The first one, which is the most common one and the one that you're gonna need obviously in your assignment, is the append operator. And if you choose this, you can actually hover over it. It's gonna tell you that append function append an object to the end. Okay, the append method, just like any function, it takes 2 parentheses at the end, and within these 2 parentheses any value that you provide gets appended to the list on the right, on the left. So when we say, for example, Ahmed, any value that you provide, Ahmed in this case is a string, that's why I wrapped it with a quotation mark. So any value that you give to this append function inside the parentheses gets appended on into the list on the right. Okay, so let's print the names after the first append, and you're gonna see this, the first append when the names was empty, it's gonna give you obviously an empty list. We appended the print after the first append is gonna tell you that names now has the value of Ahmed that you have appended. Now let me just discuss a quick terminology with you. I've kept saying the append method. So what is the difference between a method and a function? Basically, when we say print, okay, this print function, this is a function. Okay, this is a function. How do you know what a function looks like? I've kept telling you from the start of the course. A function is basically any name followed by two parentheses, and this is in any language. Okay, a function is any name followed by two parentheses. This is called a function. So if you look closely, append has the same exact meaning. It's like it's a name called append followed by two parentheses. So why do we keep calling the append method? Why don't we call it the append function? Basically, when you see any function like append in this case, if it was preceded by a dot operator, okay, this shape, which is basically a function preceded by a dot operator, is called a method. Okay, and you wouldn't find a method like hanging out like this by itself. The dot operator is actually the access operator. So basically, if you see a dot operator, definitely there's gonna be something on its left. In this case, it's gonna be definitely a list on the left of this dot operator. So maybe names, for example. So this is an append. When you take a course called object-oriented programming, you're gonna understand more about methods, and you are going to create your own methods. Like we're gonna, like in the next year, for example, we're gonna create our own append function and our own sort and reverse functions, which I'm going to talk about shortly right now. Okay, so remember that this is a difference. The method is basically a function, but preceded by a dot operator and preceded by some sort of an object. But the function doesn't have a dot operator before it. It's just a function that stands alone like this. Okay. Now let's make another append, and I'm just gonna copy this part here. So let's append, for example, Ziad, and let's append. Okay, let's print the names list after the second append. So you're going to see Ziad coming to the end of the list. It's gonna be appended after Ahmed. That's what append means. It's gonna be appended after the previous element or the last element. Let's make another append and call this Barry, like this. Okay, and let's print. You're gonna see Barry comes to the end. Okay, this is basically append. Now there's another method called sort, which basically sorts the elements. If you see what happened in the last append, what got printed is basically the order of the append. You have appended Ahmed, then Ahmed here, Ziad, the next append, Barry was the third append. That's why we have the list in this order. Okay, if we said something like names dot sort, and basically you don't have to give an argument inside the sort parentheses, just leave it like this. Okay, and you went and said print names, just check the last print after the sorting. You see that Python or the dot sort method actually sorts the elements based on their first alphabet if they were strings. Okay, so B comes before Z and stuff like this. Okay, now let's take this out. I'm just gonna comment this out, and let's say names dot reverse. Let's just see what reverse does. Notice something, that sort has actually sorted the elements based on their alphabetical order. Okay, But reverse, what does reverse do is basically that it will just reverse the elements without any actual sorting order. It just reversed the elements. So we're gonna see Barry at the start, then Ziad, then Ahmed. Okay, so let's run. Okay, let's run names. I'm sorry. Let's run names. You're gonna see that's our list after the first 3 appends. It's just gonna reverse them without any order. Barry, Ziad, and Ahmed. Okay. Okay, let's make another append. And let's say that we are going to append Ahmed one more time. So you're gonna see that we have Ahmed and Ahmed. Basically, remember that you have reversed the list. That's why you are seeing the list in this look. Okay. So if you want to use the count function or the count method basically takes an argument and it returns the number of frequencies or the number of occurrences of that element. So let's say that we want inside the names list to count how many times does Ahmed, the element, appears. Okay, you need to wrap this inside a print function in order to see the number or the count that is being returned. Okay, so it's gonna tell you that Ahmed has 2 frequencies or 2 appearances or 2 occurrences. Which are those? Let's see how many times Ziad, for example, appears. It's gonna tell you have 1 instance of Ziad in this list. If you type something that is not basically there, it's gonna tell you that there's 0 count for this whatever you have written. Okay. Now, for just one last example, I'm just going to comment everything out, and I want to show you that we can use these list methods on numbers as well. So let's say that we created an empty list called numbers. Okay. Now let's append to numbers. For example, let's say 9, and this is basically an integer. Let's append as well 3.3, which is a float. Let's append, for example, 8. Okay, this has no order if you like pay close attention. Let's now print the numbers. It's gonna give you 9, the first append, the second append, and the third append. Okay. Now let's try this sort and see how this sort works. Let's say dot sort, and let's print the numbers at the end. Basically, sort works on numbers as well, so it sorts them from the least or from the smallest one to the bigger one, ascendingly. There's an argument that you can actually provide to sort if you want to sort them descendingly. You can just say reverse and put the value of reverse is true. In this case, it's gonna return them sorted descendingly. 9, 8, then 3.3. Okay. Now let's comment this out and let's see what does sort give us. Basically, remember that your append has this following order. If you said something like numbers dot reverse, then you said something like print numbers. Basically, it's just gonna reverse them. So we have like 8, 3.3, and 9. Okay, and you can use count to check how many elements of the thing that you're searching for inside the list on the left. Okay. Right, so to recap what we did, we said that we can use the variable of the for loop as a number counter, and this means that you're going to have a range function with any stored parameter and any end parameter after the n operator inside the for loop header. So basically, in this case, you're going to the x or the variable of the loop of the loop is going to be storing 1 to the end of this range, which is 1 to 10. And we said that we can use the for loop variable to access an element in an iterable. In this case, we are using a list, for example. Basically, we can use the same concept on a string. So for element in list, element is the variable of the for loop, and this can be x, just as we have used x here, or can be y, a, z, b, any variable. Okay. So for element in list, directly after the n, you place the list name, like this list we have here. The element is gonna be each element of this list in each iteration. So this for loop is going to continue for 5 iterations because we have 5 elements. The first iteration, the element variable of the for loop is going to be 10. That's why 10 is going to be outputted. The next iteration element is going to be 666. The element in the third iteration is going to be 99, and so on. Okay, just to reiterate on using the for loop variable to access an iterable element, we said here that I think it's in the same file. Yeah, let's just take this. Okay. In this example, we had an iterable. And this iterable in this case was a list. Okay, the list name was it was called courses. And when we said for x in courses, x was each element in this list, we can use the for loop to access the elements themselves in another type of iterable, which is the only the second iterable that we have taken so far in this course, which is the strings. Okay, so we can say that we have a string, for example, called for example Ahmed. We can say for x and string directly, just as we have used here for x in courses directly, for x in string directly, we can say print the x, and this is going to be basically this iterations, or the iterations in this for loop is going to be for one iteration, 2, 3, 4, 5. We will have 5 iterations. In each iteration, the for variable, or the for loops variable, which is x. In the first iteration, x is going to be a. In the second iteration, x is going to be h. In the third iteration, x is going to be m, and so on. So if you print this, you're going to have each character or each element of this string printed in a separate line. Alright? Alright. Now, we have discussed the list methods. We have talked about the append, sort, and reverse. And yeah, we talked about count as well. Now, I remember most of the groups have done this example inside the lab. This is just to reiterate on this program because it's really important. Basically, this program is not the important one. The important thing is the enhancement of this program, which is program 2. So you need to do program 1 again in order to do program 2. If you have done this already before, you can skip this if you understand it and just jump right ahead to the second program. So let's see the program 1. What does it say? It's telling you to ask the user to enter 3 degrees. Okay, basically we're entering 3 degrees, so we have a variable for each input. Okay, degree 3 for the third input, for the third degree. And notice that we have the integer casting function to cast whatever input the user is gonna enter to an integer, and we have an empty list called marks. We are initializing it with an empty list like this. So the program is saying if each degree is greater than or equal to 50, so we're gonna compare each degree to 50. If it was greater than 50, append that degree to the empty list that is called marks. Okay, by the end, just print the marks list. There are no loops intended in this program. So let's see how can we approach this. You can just copy these 4 lines to your workspace. I'm just going to create a new script. Let's say that this is going to be, let's say, I don't know, maybe program 1. I already have something called program 1, so I'm just going to say, yeah, P1. Okay, so we have this 3 degrees in 3 separate variables. You can say something like this: if d1 is greater than or equal, remember greater than or equal is written like this. Always in every language, the equal sign is going to be on the right of the greater than or less than. If it was greater than or equal to 50, don't forget the colon to make sure that there's an indentation at the start of the block. Then append to marks the following degree, which is d1. That is the degree that we are comparing. Okay, if degree 1 is greater than 50, append d1 into marks. Okay, we are going to need another if statement, another 2 if statements for d1 or for example for D2, and there is another one for D3, like this. Okay, that's basically the program. And by the end of the day, we should, oh my goodness, we should print marks. Okay, now let's run this. So this is the first prompt that we are getting, the first line. So just enter the first mark as 44, the second make it like 88, any number. I'm just making like some variety here, so let's say 66. So basically you're gonna notice that the only marks that got appended into the empty list were the ones who were actually greater than or equal to 50, which is 88 and 66. Now some of you had made something like this, like most of you were saying if D1 is greater to 50, or if D2 is greater than or equal to 50, or D3 is greater than or equal to 50. Some of you tried to do this in one go, in one if statement. But the thing is, if you were using the OR, you can't actually append multiple values. You can, inside the append statement, you can only append one value. You can say something like comma and D2. This will not work. This is going to give you an error. If you want to append multiple values, refer to the document of the third lab. You're going to see a method called .extend. .extend actually lets you append multiple values, but that's not even the case here. So basically, if you were appending one value at a time, so if this was greater than 50, alright, append D1. If this wasn't, maybe D2 is greater than 50. So what are you going to do? Like, are you going to make something like marks it append one more time, saying D2? So what's happening here? So maybe D1 is greater than 50. If this was the only one that's greater than 50, notice that the D2 and D1 and maybe as well D3 will be appended. And this is not what you want. Maybe the first 2 degrees were only greater than 50. So this is going to give you true, but this is going to give you true. By the end of the day, you're gonna find some excess degrees that were not even greater than 50 being appended. So this is not a correct thing or a correct way to think. Maybe you're gonna think, maybe I'm gonna do this OR and make it like an AND gate or an AND operator. Basically, you're saying here in this if statement, if D1 is greater than 50 and D2 is greater than 50 and D3 is greater than 50, then append the 3 marks. And this is correct, but this if statement will only evaluate true if the 3 degrees were greater than 50. But if one of them wasn't greater than 50, then you'll find yourself gonna need elifs. So you're gonna say, okay, if this wasn't the case, maybe you're gonna search for the possible combinations. Maybe the first degree one was greater than 50. Yeah. If this is the case, maybe append D1. You're gonna need another elif for D2. Maybe it was greater than 50, then append D2 by itself. So by the end of the day, you're gonna find some other possible combinations that you're gonna like write it by hand. So I believe that in this type of question, the easiest solution is if you have like 3 degrees. The easiest solution, take into consideration the easiest solution without using loops, is by having an if statement for each condition, for each degree. That's the easiest thing that you can think of. And basically, you wouldn't make an elif regarding, because an elif means that you are trying to connect the first if to the second if. And elifs basically works on a single variable. You can say if degree 1 is greater to 50, then you're gonna say else if degree 2. If and elifs works on the same variable, so you should say something like you're gonna continue comparing to the same variable that you started working on in the first if. That's the thing with elifs. That's why we have used separate if statements, because you have separate degrees, so separate ifs for an if for each degree is the thing that you're looking for. Alright, I hope this is clear for you. Okay, so this is the easiest solution. Now, program 2 is telling you enhance the previous program using a for loop. Okay, now without continuing the program, without continuing reading the rest of the program, let's just see how can we use a for loop to enhance this process and make this process kind of iterative. Okay, the point of the for loop is, instead of taking 3 variables and making 3 if statements and making 3 append operations, a for loop shines in this part. You can make a for loop that runs for 3 iterations or runs for 3 times, and in each iteration or in each time the for loop runs, you're gonna take one input. This one input, you're gonna use one if statement to compare it to 50, and you're gonna use one append operation to that one input that you have just taken and compared. Okay, this is where the for loop comes in handy. So basically, a for loop actually minimizes the number to a single operation, a single if, a single append, a single input. So we're gonna take out all of these if statements. I'm gonna just leave myself with one. I'm going to take out these inputs. Okay, now let's see how can we think about a for loop to run for 3 times. Let's say that for x in range, and you should ask yourself, why did I use range? Why didn't I just use for x in marks? Basically, when I told you that you can use for the for loop variable inside the list, like the one we did here for x variable inside courses, or for x variable inside a string, the thing is, this list had elements, it had some stuff inside. So basically this loop is going to go for 3 iterations because we have 3 elements, and this loop is going to go for 5 iterations because we have 5 characters or 5 elements. But in this case, for x in marks, this does not make any sense because we started marks with an empty list. So you're saying for x in marks, which means that this loop will never run because marks doesn't have any elements. So basically we don't have any iterations. There's no loop. So this doesn't make any sense. The thing is, we need to make this for loop runs for 3 times or 3 iterations. Why is that? Because we have 3 degrees to enter. So basically, let's say that for x in range, notice that I needed range because we needed the loop to run for 3 times or 3 iterations, which means that we need to use the loop as a number counter. Okay, so for x in range from 0 to 2, basically this gives you how many iterations. This gives you the x will be in the first iteration equals to 0, then the second iteration is going to be 1, then the third iteration is going to be 2. So we have a total of 3 iterations, 1, 2, 3. If you didn't like starting from 0, it's fine, you can say from 1, but increase the end to by 1. So let's say that the iteration of the x in the first iteration is going to be 1, the second iteration x is going to be 2, the third iteration x is going to be 3. Okay, 1, 2, I think this should be 4. Yeah. So we have 3 iterations as well, but I have just increased the end by 1. Okay, so I'm going to go for 0 to make the start on 0. Okay, so from 0 to 3 we have 3, 1, 2, which equals to the number of 3 times or 3 iterations. Okay, remember the x variable of the for loop, we are working on the x variable using the range function. So basically we are treating the for loop as a counter, a number counter, right? So when this loops start, I want to take an input from the user. So I'm just going to copy this input inside the for loop block, and we don't really have numbers anymore. So I don't need to make, or I don't need to name this variable as d1. Let's just make it d for degree, and we don't have a count anymore. So let's just make the prompt as enter the mark. Okay, so once we have the mark, let's just compare it. So I'm going to place this if statement inside the for loop. Okay, don't forget that you have an indentation after the if statement, like you're saying that this will happen inside this if statement. Okay, you need to have this indentation right here. Okay, so if d, we don't have d1 anymore, so if d was greater than or equal to 50, we're gonna append the d or the degree inside the marks list. Okay, so this is gonna continue for 3 times or 3 iterations. So we're gonna basically input 3 degrees. Okay, because you are setting the counter, the for loop counter for 0 to 3, which is 0, 1, 2, which is 3 times or 3 iterations. Okay, so let's try to run this. This is the first iteration where x is equal to 0. The program is gonna ask you to enter a mark. Let's say 44. Okay, so basically what happened is Python went to the next line after just when we pressed enter and we have finished entering the first mark. Python went to the next line, and it compared the degree that you have entered, which is 44 to 50. It wasn't greater than or equal to 50, so basically the whole if statement was skipped. Python, what did Python do? When it finishes this if statement, either by executing it or like skipping it in this case, it went after the if statement. It went to the final line after in the for loop block, which is here. It found out that it had finished executing all the lines, but remember, the loop will never execute. Python will never get out of the loop. The control of the program will never get out of the loop like this. Okay, it's gonna be whenever it reaches the final line in the for loop, which is this line, for example. When it reaches here in this case, it's gonna go back to the header of the loop and checks, did we reach the final iteration? Did we reach our last iteration or not? If we did reach the final iteration, we're just gonna do this to get out of the loop and execute whatever on the same level as the for loop, on this level. But this is not the case, because x has 3 times to run. It's gonna be 0 in the first iteration, which we have already finished by entering 44, and the next iteration starts now, and x is equal to 1, indicating that this is the second iteration. The input function or the input line has been executed, and it's asking me to enter the mark once more. So basically, if we entered 66, for example, and you hit enter, what happens is the previous 44 that has been entered and stored inside the D variable has been updated. It has been updated to 66. So it's basically as if we were like overwriting the value of the previous iteration, which was 44, into 66. Now the D has 66, so basically it's comparing, is now 66 greater than or equal to 50? Yes, it's definitely greater than. So Python is going to enter the block because this condition has evaluated to true, and it's going to append the value inside the D variable, which is in this case 66 that we have just entered right here, into marks. So basically marks now has one value, which is 66. Python will go after the if statement and checks, so did we finish all the lines in the for loop? Yes, we have. So what's next? Do we get out of the loop like this, or do we continue running the loop? Well, the answer is yeah. We will go back to the header of the loop and check, did we reach the last iteration or not? Well, basically now we are on the last iteration, which is x equals 2, which is the third iteration. Now the third iteration has been running, and it asked me to enter the marks once more, or for a third time. So let's enter 77, for example. Once you hit enter, 77 is going to be stored inside the D variable. It's going to be updated or overwritten inside the D variable. Now D is 77. Is it equal or greater than 50? Yes, it is greater than 50. So append the value inside D inside marks. So marks now have 77. Basically, when Python comes to the end, it does not go out of the loop. It does the same exact thing. I know that you got bored of this, but it's me just reiterating stuff so you can like understand what's going on. So Python comes to the final line here, which is this line. It checks, do you have something next to execute? There is nothing next to execute, so go to the header of the loop. Now when it comes to the header of the loop, it's gonna find that x had finished all of the numbers or all of the iterations here. So basically every iteration has been done correctly. We have executed all of the 3 iterations inside this range. So once Python realizes that the variable of the loop has been like finished all the iterations, it just does not execute anything anymore, and it just like goes out of the loop. It ends the loop or exits the loop like this. Okay, and it goes down to find anything else to execute. You're gonna find that there is a print of the list at the line of 32, so it's gonna print the marks list, which has 66 and 77. Okay, because these are the only 2 inputs that we have entered that is greater than 50. All right, so basically we have made the process iterative of the first program. We have used loops in this program, but what does program 2 actually is asking is, in this program, enhance it using a for loop, and there is an extra thing to add, which is basically asking the user to determine the number of degrees that he or she wishes to enter. So basically, if the user, what if the user wanted to enter like 4 degrees or 5 degrees or 6 degrees? Remember that the range that you have set is a static range. So basically, you have specified inside of your program that the loop will continue from 0, 1, and 2. So this is gonna this actually equals inputting 3 degrees. So basically, what the program is asking you is you need to make this end, which basically defines the number of iterations, aka the number of degrees that you should enter. You need to make this end dynamic. You need to make this end decided or determined by the user. So let's say instead of 3, let's make it like an n or an x variable. Okay, and let's just take an input before the loop starts, and let's name it n because we named the end here as n. And let's tell the user something like, how many degrees do you wish to enter? Okay, there's a W here. Okay, so if the user entered, for example, 4, so this loop is going to start from 0 until 4. So the iteration is going to be 0, 1, 2, 3, which equals to 4 times or 4 iterations. So he's going to enter 4 marks. Okay, if the user have entered 5, so this is going to be from 0 to 5, which is going to be 0, 1, 2, 3, 4, which equals to 5 iterations. So the user is going to enter like 5 degrees. Okay, but the thing is, don't forget that the input functions or the input function saves anything as a string. Even if you hovered over the n, you're going to find that n is a string, and range function does not accept any strings as arguments. It only accepts numbers from a start to an end. So don't forget to cast this input to an integer. Okay, now let's just remove this comments. Now let's run the first iteration, or the first input is going to ask you how many degrees do you want to enter. So let's say that you're going to enter like 2 degrees. Notice that the for loop is going to run for an iteration of 0 and 1, like 2 iterations only. So we're going to see this statement being printed on the terminal twice only. So enter 33, for example, and 77, and that's it. The only one that's got appended is the one that is greater than 50. Okay, so now program 3 is asking you, you have the following marks list. Using loops, get the summation of elements in this list. So I'm just going to copy this list in my program. Let's comment this out. We have this marks list. This list contains 7 marks, 7 elements. So remember that every time we wanted to get the summation of something, we always used to make a variable called sum and set it by 0 at the start. Notice that getting the summation of the elements means that you're gonna have at the first element 30. You're gonna add the second element to the first element, which is 55 plus 30. This is gonna give you 85. Plus in the third element, you're gonna add 40 to 30 plus 55. And the fourth element, which is 55, is gonna be added to 30 plus 55 plus 40. So you need to accumulate these values. And in order to accumulate these values, you need to know how can you iterate through these values. And when I say iterate through these values, I basically mean that you're gonna need a for loop. Okay, iterating over the values mean that I'm going to stand on this value, I'm going to be at this value at some sort of iteration, at some sort of point. So if I'm at this value, I can do something to it. I can add it, I can append it, I can do whatever I want. The second iteration, which I'm going to iterate through, it is the second element. Then I'm going to iterate through the third element, then iterating through the fourth until the last element. This is what we mean in programming by iterating through elements. And you're gonna basically need a for loop. Okay, so let's start with the thing that we know. For x and what? That's the real question. If you said for x in range, like range, what is the start and the end of the range? Let's say the start is the first element, which is 0, and we want this loop to have the number of iterations that equals the number of elements in this list, which is 7 elements. So basically, if you said from 0 to 7, that will work because we have 0, 1, 2, 3, 4, 5, 6. So basically, we're gonna get 0 to 6 because the 7 is the end is excluded. And one of you might ask, what if we said something like from 0 to the end of or to the number of elements of the list, which is len of marks. Len of marks as well is gonna return 7. So this is the same exact thing as this one. But the problem is, if you set something like this and you set like something like print x, what's gonna be printed is the numbers, the indices. X in this case is a number counter. It's actually the indices of these values. So x is gonna be the index of the first element, which is 0, and the index of the second element, which is going to be 1, till the index of the last element, which is going to be 6. And this is not something that you want to do. Maybe you want to access the elements themselves, so you might want to do something like this: marks of x. In this case, marks of x is going to return the actual element. So in the first iteration, x is going to be 0, and x is going to be substituted inside the loop block by the value of the x in that iteration. So it's going to be marks of 0, which is going to return 30. In the second iteration, x is going to be 1, so marks of 1 is going to return 55. In the third iteration is going to be marks of 2, which is going to return 40. So let's just say marks of x, and let's run the output and see. So basically, when you say marks of x, you get all the elements themselves, not the index of these elements. And I told you that there's an alternative. We have discussed this, by the way, in the third lab. There's an alternative for making our life easier instead of doing all of this, and I have talked about it in the first of this video, in the first bit of this video. Instead of using range, and instead of using this marks of x stuff, which actually seems a little bit work to do, we can say for x in the name of the list itself, right? For x in marks, just like this, for x in marks, for x in the list directly. In this case, the element or the variable of the for loop is going to be the element itself. So if I did something like this and print, this is equivalent to what I have written before, like a moment ago. So for x in marks, x in the first iteration is going to be 30, x in the second, which is going to be printed here, x in the second iteration is going to be 50, x in the third iteration is going to be 40, till the last iteration where x is going to be 25, and this is what is going to be printed. Okay? Now notice something. We don't really want to print the elements. We want to get the summation of these elements. Okay, so basically the summation was something like this: sum equals sum plus x. What is really happening here? So let's start by saying that we have sum before we enter the loop. Okay, we have sum that equals 0. Okay, we enter the loop. This loop is set to run for how many iterations? You get it right? For 7 iterations. Okay, so this is gonna run for 7 iterations. Right. Okay. So in the first iteration, x is gonna be the first element. So we get into the for loop block inside the block itself, and we try, our Python actually tries to execute this line. So when this line is executed, remember that Python always evaluates the right hand side first, then puts whatever value that results from this right hand side into the variable on the left hand side. So basically we start by sum that is equal to 0, and the x in the first iteration equals to 30. So basically what's happening in the first iteration is something like 0 plus 30, and the total will be 30. 30 is being stored in sum. Now the for loop finishes this line and continues, and it finds that there is no next line, so basically it goes back to the header of the loop to execute the next iteration, which is basically the x when it's equal to 55. So basically this right hand side part evaluates one more time. So remember the sum, the previous sum, the sum from the first iteration was 30, right? That was the last thing, the last value that we had. Now sum, which is 30, plus the x, which is now the second iteration, which is the second element, plus 55, this is going to give you something like 85. So now what's going to be stored, the new value stored in sum, is going to be 85. Okay, so that is the next iteration. Basically Python goes to check if there is another line inside the for block to execute. There is no other line, so it goes back to the for loop header, and it checks the third iteration where x is going to be equal to 40. Okay, so it goes inside the for loop block. The previous sum from the previous iteration, which was the second iteration, was 85, plus the new x, which is the third iteration or the third element, which is going to be 40. Okay, and the result of this is going to be 125, and this is the new value that's going to be stored inside the sum, and it's going to keep doing this until it reach the 7th iteration or the 6th element, the 6th index, which is 25, the last element. So when this finishes, when this loop finishes, just exit the loop, and by the end of the day just print the sum. Run this and you should have something like this number. Okay, so the second program is telling you to get the or print the even elements from that list. It's the same, actually, it's the same list, but the program wants to print the even elements only. So let's just comment this out, and I'm going to need this list again. We're gonna iterate through the list using a for loop once more. So let's say for x and marks, to make the x the actual element, not the index of it, it's the actual element. This loop is going to continue, it's the same exact fashion, it's going to continue for 7 iterations because we have 7 elements. Okay, so let's say that we are in the first iteration where x equals the first element, so x now is equal to 30. If 30, which is x, was or if x, which is equal to 30 in this first iteration, if I divided that x by 2 and it gave me a remainder of 0, we're gonna print the x in this case, because if it gave me a remainder of 0, this means that the x is an even number. So this is what we want, right? We want to print the evens. Okay, so now you can print the x. In the second iteration, 55 is going to be the new x of the second iteration, so 55 over 2. If this gave you a remainder of 0, then print it. And obviously 55 is an odd number, so basically this if statement condition is not going to evaluate to true, it's going to be false. So basically the whole if statement is going to be skipped, and the next iteration is going to be ran, where x is going to be the third iteration, the third element. So if 40, which is it's x in this case, if x, which is 40, is divisible by 2 and the remainder is 0, this means that there is no remainder, which means that it's an even number, so print this x. Okay, this is basically the program. If you run this, the only evens that you get is 30, 40, 20, and that's it. Now let's discuss something called tuples. Okay, so from the title here, we can see that a tuple is basically a list, but immutable, just like strings. Now let's see what does this supposed to mean. Let's say that we have this list here. Notice that in lists you can put redundant data, meaning that you can like copy a piece of data multiple times. In this case we have 2 copied twice, and we have Ahmed occurred twice in this list, and it's fine by lists. This is fine with lists. Okay, we said that we can access an element using the square brackets always. So what does this mean? I told you, like, you should use the list name followed by 2 parentheses, give it an index of the element that you want. Let's say that we want to get the first Ahmed in this list, which is of index of 2, because 0, 1, 2, so it has the index of 2. So list of 2, if we printed this is going to give you in the output Ahmed. Okay, this line. Now we talked about reassignment as well, and we said that we can change a value in a list to another value. So basically, if you want to reassign the first Ahmed that occurs in this list, which is at the position of 2 or the index of 2, to Mahmoud, you're going to say something like the place where Ahmed is in the list, which is list of 2. We're going to set this to a new value, something like this. So Mahmoud is going to be assigned to the position of 2, assigned to whatever value that was lying in this position at the index of 2. So this is going to replace Ahmed. If you want to make sure of this, let's just print this list and see what's going to happen after the assignment. After the assignment, you can see that Ahmed has been changed into Mahmoud using this reassigning line. Okay, now what is basically a tuple? Let's say that we have this list. Okay, I'm just going to copy this here, and I'm going to use a variable called t. You can use it anything, it doesn't have to be t, equal this list. Now we're going to tell me that, I mean, what have you done new here? There's nothing new. This t variable is basically a list because it starts with a square bracket and ends with a square bracket, right? The thing that makes the tuples different than the lists is the wrappers. And by the wrappers, I mean what you contain the elements with. So basically, if you change this square bracket to a parenthesis here and a parenthesis there, this, ladies and gentlemen, is called a tuple. So basically, a tuple is the same thing as a list. It can hold data that are actually occurring multiple times. That's fine with tuples also. It can hold multiple data of multiple types. See that this tuple, for example, it has a string and it has a number or an integer, and it's fine. Okay, it's the same thing as the list, except that when you define a tuple, this is what's called a tuple definition, and this is what's called a list definition. Okay, when you define a tuple, just make sure that there is a parenthesis at the start and a closing parenthesis at the end. That's the only difference. We have another difference that we're going to talk about, but this is the first difference. Okay, so let's see how can we access an element of a tuple. It's the same exact fashion that you want to access an element inside a list. If you want to access an element inside a list, I told you, just write the list name, follow the list name with 2 square brackets, and enter the index of the element that you want. With a tuple, it's the same thing. Write the tuple name, follow the tuple name with square brackets. Inside the square brackets, put the index of the element that you want. Maybe you want to get, in this case, the first Ahmed as well in this tuple, which is at index of 2. Yes, the indices have the same order, 0, 1, 2. So if you said t of 2, this basically is going to give you the element Ahmed, the first Ahmed in this tuple. So if you run this, you're going to see this print statement give you Ahmed. Okay? Now, notice something. In the list definition, we used square brackets. In the tuple definition, we used parentheses. Okay? In the list accessing, when we wanted to access an element in a list, we used square brackets. In the tuple accessing, when we wanted to access a tuple to access an element in a tuple, we also used square brackets. So a thing to take into consideration is when you're accessing any type of structure, either it was a list or a tuple, you access always with square brackets. But when you define or create a tuple, you use parentheses. And when you define or create a list, you use a square bracket. Okay? Alright. Now, the second and the most important difference between tuples and lists is that if you try to reassign an element, let's say we're gonna change Ahmed, which is the first Ahmed in this tuple, to Mahmoud, for example. So basically Ahmed at the index of 2, 0, 1, 2. So basically if you try doing something like t of 2, which is basically the third element, you're trying to replace it with Mahmoud. Before even you run, it's gonna give you a small warning here saying that t does not support item assignment. And this is the major difference between a list and a tuple. In lists, you can reassign any position with any value that you want, but in tuples, once you created the tuple this way, you cannot change it. You cannot update any elements. It's the same thing as a string. You remember that example when I told you that we have a variable called name that has the string Sam, and I wanted you to switch the value inside Sam from Sam to Pam. So you try doing something like this. The first element, which was at the index of 0, we wanted to set it to Pam, or we want to set it to P in order to make the Sam becomes Pam, right? Strings actually was the same deal here. Strings told you that you cannot do item assignment. You can't change a character in a string. It's the same thing with the tuple. You can't reassign or change an element in a tuple. Okay. Now, okay, so to recap on what we have just said about the tuples, we have here a list, a string and a tuple, and all of these are called iterables. An iterable meaning that each one of them is a collection of elements. This is a collection of elements, and the structure of this collection of elements, because it starts with square brackets and ends with a square bracket, is called a list. This is an iterable, and it's a collection of elements. In this case, it's a collection of characters, because it has a starting of a double quotation and an ending of a double quotation. So we say that this is a string, and this is a collection of elements, which is basically an iterable as well. And this iterable is starts with a parentheses and ends with a parentheses. That's why we call this a tuple. Notice that these variable names are just variable names. It doesn't have to be a list. It doesn't have to be tuple. It can be anything. You identify a list from its beginning and ending symbols, as well as the tuples. All right. So in lists, you can access an element. The accessing of an element inside a list is using the list name, then square brackets. The accessing of elements or characters in strings is using the variable that hold the strings, which is word in this case, followed by also square brackets. The accessing of an element in tuples includes having the tuple name or the variable that holds the tuple, followed by 2 square brackets. Inside the square brackets of each one of those is the index of the element that you are willing to retrieve. So if you want to retrieve the 100 from the first list, you say list of 0. You want to retrieve the m, so list of 2, because 0, 1, 2. Okay, string, you want to get the d from deal, so you're going to say word of 0. You want to get the a, which is basically 0, 1, 2, so word of 2. You want to get the 100. You want to get the 100 from this tuple, which is at index of 0, so you're going to say tuple of 0. You want to get the m, so 0, 1, 2, so tuple of 2. Okay, this is going to get the m. We can slice the 3 of those things. We can slice the list. Okay, if you want to slice the first 3 elements, you're going to start from 0 to 3, 0, 1, 2. Okay, you can slice a string if you want to get the first 3 characters, so you're going to say 0, 1, 2 from 0 to 3, because the third one is not with us. If you want to slice a tuple, it's exactly the same thing. You want to slice the first 3 elements, so you're going to say the tuple that holds the variable name that holds the tuple, which is tuple in this case, from 0 to 3, which is 0, 1, 2. So 100, 200, and the thing that makes a tuple and a string different than a list is the reassignment. Let's say that you want to reassign whatever value that has been inside the list at the index of 0 to 100 or 900. So basically you're updating whatever was inside the list at the index of 0, which is 100, into 900. 900 is being placed inside this position, the index of 0. And that's fine. So basically the new list is going to be 900, 200, MZ. In strings, if you try to reassign an element, let's say that you want to change the 4th element, which is at index of 3, from L to F, making it from deal to def. So word of 4, if you try to change whatever the character inside this position, okay, basically we don't have actually, this is supposed to be 3 because we don't have an index of 4. It's just a minor mistake. Okay, we don't have something at the index of 4. We have 0, 1, 2, 3. Okay, so even if it was 3, this will not work. Okay, strings do not support item reassignment. The same thing goes with a tuple. Let's say that you want to change the 100 in this tuple from or the value in this tuple from 100 to 900. This value lies in the first index, which is the position of 0 or the index of 0. So if you try to reassign whatever inside the index of 0 to 900, this is going to give you an error, just as I showed you in the illustration. Okay, so now let's talk about something called functions. I think you know what functions mean, or at least how you can use them from what we have used in Octave or MATLAB in the first semester. A function is basically a black box. Okay, let's say, see this program that we have just made here, where we actually check if an element inside the list is even or not, which was program 4, I guess. This code, we have written this code like you have just pressed like white spaces like this, and you chose like a proper area for you inside the script, and you decided to write the code like this just immediately. What happens is, when we say using function write the following program, what happens is instead of like writing all of these lines like in the middle of nowhere inside your script, you're just gonna cut this and paste it inside a function block right here. Okay, that will be what we mean by using function. So a function is just a box that contains the code that you have written. By default, all of what we have been doing so far was writing our code in any place in our script, in any line, in anywhere. When we are using function, we are going to place the same exact code inside a box or inside a black box called function. Okay, it might sound a little bit trivial, and you're gonna ask yourself, why are we doing this? The goal behind function wouldn't really shine with the simple examples that we are using inside the lab. But in future, when you hear something called modular programming, when you hear the word modular, you should know immediately that modular means using or adopting the use of function or functions. Okay, and modular programming is a very important topic in software engineering. So basically, you need to know how to use function. Okay, so let's see how can we define a function. Let's make another program and call it p, for example, 2. Let's say that we are making a program that adds 2 numbers. Okay, a program that adds 2 numbers. Okay, let's say that we have a variable called n1. Let's just use static values in this example. So we have n1 with let's make it 6, and n2 is like 4. Okay, so obviously if you want to add 2 numbers, you're gonna need another third variable called n3, x, z, whatever, which is gonna be n1 plus n2. Okay, I know this is really easy, but I want you to consider something. When you say adds 2 number, the most important thing is this line, because it has the addition operation and it has the 2 operands, okay, that you want to add. Okay, and it has the third operand that stores the result of these 2. Okay, so let's see how can we do the same exact code that we have written like in the middle of our script here inside a container. And with a container I mean inside a function. Okay, so functions has 2 stages or 2 phases. The first phase is defining the function. So how can we define a function? You use a keyword called def, okay, which stands for define. Then you write the function name, and the function name can be anything of your choice. It can be add2, it can be add nums, it can be add numbers. I'm horrible at typing, but whatever. Add numbers, add nums, add2, it can be just add, whatever. It's the function name is of your choice. So I'm just going to make it add2. Okay? After the name of the function, you need to place 2 parentheses. Okay? That's really important. Then you're going to put a colon just to indicate that anything that comes after this line is related to this function. Anything that comes here is actually a part of this function block. Okay, and basically if you remove this indentation, this means that you have exited the function or you have ended the function, and anything that comes afterward is irrelevant to the function add2. Okay, so what do you want this function to do? Remember, you need a function that adds 2 numbers. So let's say that this function takes 2 numbers. Let's say that these numbers are gonna have 2 placeholders, x and y. You can make it like a and b, you can make it like n1 and n2, whatever. Okay, let's just make it x and y. Okay, these x and y are called parameters. Okay, so what are parameters? Parameters are basically variables, just variables or placeholders that do not have any value yet. Okay, so the parameters are variables that do not contain any value. These are just variables are places that you are getting ready in order to receive from the user a value inside each one of them. Okay, so they are just placeholders. Okay, holders. Alright, so what happens inside the function is the following. You want to add two numbers, right? Okay, so let's just say x and y. So you're gonna need a third variable to store the value of x and y inside z. Whatever the value is gonna be x and whatever the value that's gonna be y, just add them together and store whatever the value that's gonna be the result of their summation inside z. That's it. You finished the function. That's all you need when you are making a function that adds two numbers. That's it. That's the most important one. Okay? Now, if you want to exit the function, you can just remove this indentation. Okay, now we have finished the first phase, which is defining the function. The second phase, which is the most important phase, is executing, or some people call it running, or the most important argument is, or terminology is, calling the function that we created. Okay, we have made a custom function, we have made it ourselves. Now we need to use it, or execute it, or run it, or call it. All of these terminologies are the same. Okay, so let's say that your second phase is basically where your program starts. Okay, now let's say that we want to use our function. I'm just going to remove all of this. Before using the function, I just want to tell you something. When you use the print function, why do you think that VS Code actually suggests or auto-completes the function for you? VS Code, or Python in this case, knows that there is something called print function. That's why when you run the script that contains a print function, there's no errors occurs, right? There is no errors that pops up in the terminal, right? Because Python knows what is a print function. The question is, how does Python know that there is something called print? The print function is defined somewhere in your Python installation. I can actually show you the place exactly. So basically, if you search for Python, you're gonna find that you have a .exe somewhere. This is the one that you want to find. Now, right click and open the file location. It's gonna give you the Anaconda download or installation directory. Now, if you went to lib, which stands for library, and you search for something like print, you're gonna find a script called ppprint, which basically stands for the script, the print function. This is where the print function is defined. Okay, so that's why when Python actually, when you write the print function and you run your script, Python knows that there is something called print defined somewhere in some script in your installation directory when you install Anaconda. Okay, it's the same thing when you try to write add2. Now, because you have defined add2 in your script in this area here, now VS Code can actually identify that there is a function called add2. So that's why it suggests it to you. So if you chose it and you give it this parentheses, everything is fine. There is no errors that occur. Let's say that you are trying to call. Remember, this phase is called the calling or using the function. Let's say that you are trying to use a function that you have never created. We have never defined a function called add numbers, for example. Now, if you run this, it's gonna give you this error. It's gonna tell you that add numbers is not defined. You have not defined add numbers anywhere in your script. Okay, but what we have actually defined is add2. So if you run this, there's a slight error that you're gonna get. It's not gonna tell you that add2 is not defined. It's just gonna say that add2 misses two arguments, which is x and y, that you have defined in the function definition. So basically, this function, when you want to use or call this function is actually waiting for two values to be passed into it. So basically, let's give it the two values that it needs. Let's say, for example, 3 and 6, 7 and 9, whatever two values. If what's happening here is basically, when you give it like 3 and 6, Python actually replaces the x, which is the first parameter, by the first value that you gave. And the order is important here. Maybe the order is not important in this specific example because you're adding, but if this was subtraction, then the order of the parameters that you pass is really important. Okay, so basically the 3 is going to be replaced into x, and the 6 is going to be placed into y in this order that you have specified or provided them. Okay, the 3 and 6, or let's say for example 4 and 5, or maybe 6 and 9, all of these values are called arguments, and you can actually tell that these are called arguments from the error that popped in the terminal. It told you that missing 2 required arguments. Okay, arguments for x and y, the parameters. So basically x and y in the function definition are called parameters, but when you actually supply these parameters or placeholders with an actual values, these actual values are called arguments, and arguments actually exist at the time when you call this function. This thing that I'm highlighting right now is called the function call, or executing, calling, running, using the function. Okay, this is called the function call, or calling a function. Okay, so if you run this now, it's not going to give you any error, and it as well will not give you any output. The reason is we haven't printed anything. You may be waiting for an output to come, like this is going to give you 15, right? So let's just try to print the value that's going to be replaced or substituted by this function call, which is what we are hoping for, 15. If you run this one more time, it's going to print none. So what is the idea here? Why is it giving you none? Why is it not giving you 15 as you expected? The thing is, when you pass 9 or 6 and 9, let's just break through the code. Let's see what's actually happening in order within the Python interpreter when Python tries to run this script. Let me tell you something. When you define a function at the start of your script or at the start of your code, basically the function definition is not read. Python does not really care about the function definition. So basically, if you have any kind of errors like this and you try to run your code, this error will be identified if you try to call the function somewhere in your script. But let's say that we are not trying to run the function anymore. Okay, now run your code, nothing will appear. Yes, there is a slight error inside the function call, but as long as you never call the function, this function will never execute. Okay, so notice that I have commented my calls to the function. So now if I run, nothing, there is no errors that will pop up to me because I never actually called the function. Once you call the function, Python returns back to the place where we have defined this function and tries to execute these lines. And when it tries to execute these lines, it's definitely going to give you an error saying that what is this variable? This doesn't make any sense. Okay, so let's take this one by one and let's see how Python actually read this script. So as I was saying, when Python identifies that there is a function at the start of the script, it actually skips this part. It does not execute this part at all. Okay, so it keeps going line by line. If there is a comment here, it does not really care about anything written after this comment. Okay, and it goes line by line until it reaches the 9th line in this script, for example. So it starts by executing the call to the function before the print. Okay, it goes for the inner function at first. So basically it tries to execute this function call that we are trying to do. So the first thing it does is it searches for something called add2. So it's going to ask itself, is there a function defined anywhere in this script that is called add2? So it's going to go back a step behind and check So it's going to go back to the start of the script and it's gonna try to check if there is something called add2 defined somewhere or not. So it's gonna find the definition of add2 at this place. So that's the first step. If there is something called add2 defined anywhere, then this is the first step to do. The second step is that it's gonna take the values or the arguments that you have provided into this function and it's gonna replace these values in the place of these parameters. So it's gonna replace x with 6 and it's going to replace y with 9. Okay, so now it's going to enter the block of the function with x that is equal to 6 and 9 that is or y that is equal to 9. It's going to find in this line that there is actually an addition between the x, which is 6, and the y, which is 9. So it's going to add x and 9 together. Okay, this will result, the right hand side will result with 15. Okay, so basically what's going to be stored inside z is going to be the value 15. This is like speaking that you have provided 6 and 9. If you provided any other two different pairs or arguments, obviously the result will be different. So what happens here? The z is going to be 15, but there's nothing being printed. It prints none. The problem is the z that stores the value 15 is actually inside this scope. It is this z that holds the 15 value. It's inside this scope of the function. It is in the function. It doesn't know how to get out of the function. It doesn't know how to get out of the function to get into this print function. So in order to return the value that has been stored in z, remember this magical keyword, that is return. Do not forget the return keyword. It is the most important keyword that you can use in functions in Python and in other programming language. So you can say return z. What does this supposed to mean is whatever value that you pass, whatever arguments that you pass to the function call, Python will replace these arguments in this or in these placeholders, and it's going to calculate the result of this operation based on the values that you have specified here. The value that's going to be stored in z is going to be the resultant of the summation. But remember, without the return z, this value that is stored in z will be kept forever inside the function. You cannot get it out of the function unless you use the keyword return. When you say return z, you're basically providing the one who uses the function, which is us in this case, with the value that he wanted to print. So if the user tried to use this function and passed 6 and 9, he should expect a value that is 15 in this case in place of this function call. And this is what Python does implicitly. If there's a return z, then 15 will be placed in this highlighted area instead of add 296 like this. So that's why when we run this, we're gonna see 15 printed. Okay. Now let's say that we will pass 5 and for example 4. So basically x and y is going to be 5 plus 4, and the one that's going to be, or the value is going to be stored in z is going to be 9. So basically when this function call get executed, this highlighted function call will be replaced with 9, which is the thing or the value returned by the function. Okay, so let's try to run this, and it's going to give you 9. Okay, so basically if you calculated anything inside your function definition, just remember to return whatever value that you have calculated, which in this case we have stored inside a variable called z. Okay, do not forget to return any value that you calculate inside your function. Alright, so someone can tell you now, what if I take this and stored it in another variable, because you know in any case this will return a value. This line eventually is going to be substituted implicitly by Python by whatever summation that this function is going to calculate. So basically if you pass like 5 and 5 and you run, what happens implicitly is that Python replaces this function call by the returned value, which is in this case 10. Okay, so if this function call by default returns a value because we have a return keyword here, we can say that we are going to store whatever value returned by this call inside a variable called, for example, result, and we're just going to print result. It's the same thing as before. I'm just doing this in 2 steps. Okay, you can actually get this function call and place it inside the print function directly. You don't have to do this in 2 steps, but if this is more readable to you, then this is fine. Okay, so try providing any 2 values and this will work. Okay, now I'm just going to take out these comments because I believe that you understand what everything means now. So basically, what we have been doing so far is we were actually providing static values inside the function call. What if we wanted to make this more dynamic, meaning that the user will be the one who decides what will be the first number and what will be the second number that we want to add together. So basically we need inputs. So let's say that we're gonna input inside the variable that is called n1. We're gonna input, for example, enter the first number, and we're gonna copy this. I'm gonna say 2, and this is gonna be enter the second number. And instead of 5 and 10, we're gonna place n1 and n2. Okay. So let's run this and enter the first number as 7 and the second number as 1, so the result is going to be 8. Okay? Alright, so if we wanted to make another function that subtracts, we can say that there is another function definition. We can define multiple functions in the same script. So let's say sub2, and let's just change the plus to a minus symbol. Okay? And let's see that, or let's say that we're going to save the result of the addition operation in result 1 and save the result of the subtraction operation in result 2. So let's call the function and pass the same two numbers that we have provided as inputs. Okay, and let's print result 1. We can print it in the same line actually. So let's say comma result 2. Okay, so now if we run and give something like 8 and 1, the summation will be 9 and subtraction is going to be 7. So this is the result 1, which is the result of the returned value of the add2 function, and this is the result 2 variable, which is the return of the sub2 function. Okay, now this example here is saying if you did the add 2 numbers, just change it to subtract 2 numbers, and we have just already done this, and we call it sub2. This example is saying, how about you make a function that adds and subtracts 2 numbers in the same function, using one function. So let's say that we are going to make another function, let's call it add and sub2. Okay? Remember that this function takes 2 parameters as well. And let's say that we're going to have a variable called z1, which is going to be storing the result of their addition, and z2 is going to be storing the result of their subtraction. The thing is, what are we going to return? Like, one will be thinking of the following: why is there a way that I can do something like return z1, and in the second line can I do something return z2? Is this even possible? Now let's try and run this. It's like you see that there is a warning. It's telling you that it's unreachable. But let's see if we had like 2 returns in the same function. Will this work or not? This will never give you an error, but instead it's going to give you another thing. Let's say that we're going to cut all of this, and we're going to use another variable called res and call the function that is called add and sub2 and give it n1 and n2. Okay? And let's print whatever is going to be returned from res. Okay, now let's try to run this. Give 8 and give 1. Remember, you expect to see the addition, which is 9, and you expect to see the subtraction, which is 7, right? So if you hit enter, you're gonna find only 9, which is basically the result of their addition. Now, what's going on here? It's really obvious that the first return is what has been executed. The first return actually the value of their addition, which is anything that is stored in Z1. And this is the thing that got printed here. And this is the thing that got returned and saved inside res variable. The next return has not been actually executed and has not been returned. Why is this? Okay, take this as a note for you. In any function, in any programming language, after the first return, anything after the first return is not seen, as the function VS Code, as VS Code is telling you, it's unreachable. Okay, so anything after the first return is unseen. Let's even say that we are going to print like any stuff like this. Let's say that we are going to take an input, enter anything, Okay, all of these stuff after the first return, all of these 3 lines are not going to be executed at all. So let's run this one more time. It's gonna tell you enter the first and the second number, 3 and 4. You're gonna see that this has returned the submission, which is 7, and that's it. All of these has not been executed. There is no print that we have seen that we saw in the terminal. There is no input that has been popped in the terminal, and there is no Z2 that has been returned. Okay, so return keyword works as the continue keyword. Okay, remember I told you after the continue keyword, anything after the continue is not seen. It's the same thing as the return keyword. Anything after the first return is not reached. Okay, so if you want to return multiple values using the same return keyword, you can just simply say Z2, Z1. Okay, remember the first thing that's going to be returned is Z1, which is basically the addition, and the second thing that's going to be returned is basically the Z2, which is the subtraction. So now let's run and see what is the kind of thing that's going to be stored inside the result variable. Now let's run and let's give 6 for example and 1. Notice what has been stored here. The thing that has been stored here is basically 2 values. The first is 7, which is their submission or addition, which is basically the first value that we have returned, which is Z1, and the second one is their subtraction, okay, which is 5, which is basically the second value that we have returned, which is Z2. Okay, now what do we call this structure? What do we call this thing that starts with parentheses and end with a parenthesis, if you remember? Yes, exactly. This is a tuple. Guys, this is a tuple. That's why I introduced the tuples to you before entering the functions. So basically, when you return multiple values within the return statement, Python returns these multiple values as a tuple format. Why actually a tuple? Why doesn't it return a list, something like this, like a list of the submission and the subtraction? Well, the reason, obviously, is because when you return stuff as tuples, you guarantee that whatever thing that you are returning from the function is secured, meaning that you cannot change the elements of this tuple. That's the point of the tuples in Python. You just guarantee that some stuff will never be changed. It's like an aspect of security regarding the values that you are returning. That's it. That's why in Python, any multiple values returned is going to be in the form of a tuple. Okay? So basically, if you want to access the first element individually, let's say that you want to print only the addition from these two variables that are returned, 7 and 5. You want to access the first element, which is, it's going to be always the addition. Why is it going to be always the addition? Because inside the function itself, you return the first variable that stores the addition. You are always returning the first variable, that is Z1, which is basically the addition. So the first element of this tuple is going to be always the addition of any 2 numbers that you insert. So basically, if you wanted to print the first number, remember, a tuple is like a list. The first position at the index of 0 and the second position is at the index of 1. So if you want to get the addition, you're going to say result 0. We can actually add a string here. Let's say result, let's say addition. It's going to be something like this. And let's say, for example, if we want to get subtraction, so we're going to say result, the second element, which is going to be 5, which has the index of 1, is going to be subtraction. Now let's try to enter something like 6 and 6 as well. So this actually returns the following tuple. When you enter 6 and 6, it's going to give you the addition, which is 12, and it's going to give you the subtraction, which is 0. That's why we see result 0, which is the first element, which is 12 here as 12, and result 1, which is the second element at the index of 1, which is 0. Okay, so this is the first way to access the elements of a returned tuple. There is another way. Let me just discuss with you some quick assignment test. Let's say that when we say that we assign a variable, we say something like x equals 70, right? This is called an assignment. We are assigning 70 to the variable of x. So basically, if you print x now, you're gonna find that x is actually 70, right? But what happens if you say something like 70 comma 90? Will this give you an error, or will this assignment work for the first value? Like, will x have only 70 but not 90, or will it have only 90 but not 70? What's going to happen here is basically that x is going to store both, but as a tuple. Now let's run this, and you're going to see that x will store both of them as a tuple. It's basically like saying store inside x the following tuple. But instead, if you didn't provide any wrappers or containers, in this case the parentheses, Python will by default will assume that this will be contained in a tuple. That's why it puts by default these parentheses. Okay, now this is called single assignment. Okay, and this is the one that we have talked about like so far in this course. We have something called multiple assignment as well. Okay, now what if we said something like y z equals 70 and 80? Okay, I'm just going to comment this x. So what happens here? What's going to happen is 70 will be assigned into y and 80 will be assigned into z by order. Okay, so let's print y, and let's print in another line, let's print z. Now run, you're gonna see that y has 70, the first one gets stored in the first variable, and z has 80, the second value gets stored in the second variable. This is equal to this, y equals 70, and on another line z equals 80. Okay, so that's how things are. Okay, so this is multiple assignment in the same line, and this is like two single assignment on different lines. This equals to this. Okay, so why am I exactly telling you this? Now remember that I told you if you entered an input of 6 for the first number and an input of 6 in the second number, this will be returned as a tuple inside the variable called res. Okay, we can, instead of using res of 0 and res of 1, we can do the following. We can unpack these values. Okay, and by unpacking mean what we have just done a moment ago. This is called unpacking. Unpacking values, or some people call it tuple unpacking. Okay, so a tuple unpacking is basically you unpack this value inside the first variable and you unpack the second value in the second variable. This is tuple unpacking or tuple unpacking. Okay, so we can do the same thing. We can unpack the values returned inside this res function. So let's say again that we are giving the first number as 6 and the second number as also 6, and what's going to be returned is the first value, which is the addition, which is 12, and the second value, which is subtraction, which is 0 if you give 6 and 6. Okay, and both are going to be stored or returned as a tuple that is going to be stored inside the res function. And instead of using the indices res0 and res1, we can do the following. Let's unpack 12 inside a variable called res1, and let's unpack the second value, which is 0, inside another variable that's called res2. Now we can do the same thing, saying that res1 is going to be 12, and we can print res2 that's going to be the second value. Okay, so let's run this and enter 6 and 6. Basically 12 is going to be the first value stored in res1, and 0 is going to be the second value from this tuple or tuple stored in res2. Okay, so this is basically the tuple unpacking. Now let's see how can we make a function called sum and average. That's the name of the function. Okay, it takes 3 degrees, as the program is saying. It should take 3 degrees or arguments, and it should print or return the sum and the average as well. Okay, so let's say here that we have a function called sum and average, and it takes 3 degrees, so x, y, z. Let's say that the summation is going to be x plus y plus z, and the average is going to be the sum over 3. Okay, that's it. And let's return by the end of the day the sum and the average. Alright? Okay, this is wrong. Let's say this and like this. And we're good. Now, let's just change the prompt to the first degree. Let's say this is going to be the 3rd degree, and let's say that this and this guy, they're going to be degree. Okay, let's remove the comments here and the comments there. Now, let's just make this n3. Now let's say that we are going to use the function sum and average, and let's pass n1, n2, and n3, the inputs. And remember, this is going to return a tuple of 3 things. Okay, so we need 3 variables to unpack this tuple. So result, I'm really sorry about this. We are going to return 2 values. I'm sorry about this. So the tuple that's going to be returned is a tuple of 2 elements. So we just need 2 variables to unpack them, res1 and res2. Now let's try to enter, for example, 10 and 11 and 12. The first one is the summation. The second one is the average. And basically notice that the average is a float, because I told you before, then when you divide anything in Python, the result of the division operation in Python always results of a float, even if the 2 operands of the division were integers. Okay? Now, let's see the next one. Alright. So problem 9 is saying that you write a function and call it sign detector. This function takes one number as an argument. Okay? So it takes one argument only. And it determines if a number is positive or negative. And it should return the word positive or return the word negative. Okay? So let's say that the function is called sign detector. So let's say define sign detector. It takes one variable. Okay. The sign detector works as follows. If the number that you have entered is greater than or equal to 0, we are going to return the word positive. Else, which is basically is going to be less than 0, we're going to return the word negative. Now, one of you might be asking now, we are using 2 return statements, so what's going on? Basically, this return statement will be executed if this if was true, and this return will be executed if this else was true. And remember, when you have an if and else, there's only one of them that's going to be executed. If this if evaluated to true, then this is the only return that we have, and this else with its return will never be executed. The same thing goes if the number that the user enters into this function was not greater than or equal to 0, so this if is not seen at all, and the else is the only thing that gets executed, so we have this return only. Okay, so basically we will ask the user to enter a number, okay, and we're gonna say that we have a variable called result, or yeah, let's call it result, whatever, and let's say sign detector, and give that sign detector the argument of n1, which is the input from the user. Okay, and by the end of the day, let's just print result, which is going to be either negative or positive. Okay, so let's run this and give something like a positive number. It's going to give you positive. Let's run and give it something negative. Let's give it 0. It's going to give you positive. Okay.